All right, here it is, Chapter 12, Section 4, Angle, Measures, and Segment Lengths. Get ready to draw some circles, y'all. Okay, so when you're drawing this on your own paper, draw a circle and a criss and a cross. Um, if two chords intersect in the interior of a circle, like right here, then the measure of each angle is 1/2 the sum of the measures of the two intercepted arcs. So you add this arc plus this arc and divide it by 2, and then you'll get the angle 1. What is the measure of the other angle? Oh, same thing, because they're vertical angles. You guys remember from previous chapters, angles that are on the opposite sides of the crisscross are vertical angles and they're congruent. So, fun. All right, so we have example 1. We have, we're going to find angle 1. All right, so we have arc of 90, arc of 122. So the measure of angle 1 is 1/2 90 plus 122. I'm going to go for my Mr. Calculator today because I know all math teachers should be able to do mental math, but in my world right now it is the morning and I want to make sure I don't mess it up for you. So we got 212 times 1/2. And you guys, there is no shame when you're allowed to use your calculator. There's no shame in using a calculator. Don't feel like you've got to risk a wrong answer so that you can look cool in front of your friends. Because I know the coolest thing is being able to do mental math. I know that's the epitome. So, but if you need a calculator, feel free to use it. So the answer is angle 1 is 106. Yay! Okay, see that one more time? So, what? What the heck? So angle 1 is this guy. His arc is right here and right here. It is not 135 and 70. So what do we do? Well, how many degrees go around a circle? That's 360. If I have 135 devoted to this piece of the arc and 70 devoted to the other piece of the arc, then the sum of these two arcs, I don't know specifically what they are, but I know that their sum is going to be whatever's left out of that 360. So we go 360 minus the 135 minus the 70. So the sum of these two arcs is 155. So the measure of angle 1 is 1/2 of 155. 77.5. All right. Let's move on. Um, Theorem 12:14, if an exterior angle, what? He's on the outside, intersects a circle, then the measure of the angle is 1/2 the difference of the two intercepted arcs. So let's write that. Let's just make a formula for that because sometimes the words are a bit much. So if we have, if an exterior angle intersects a circle, so we have, let's call this A, B, and we'll throw C here. So we'll call this angle 1. So the measure of angle 1 is 1/2 the difference of the two intercepted arcs. So like ACB minus AB. It could also be it doesn't have to be tangent. So if you're in this land, it would be CD minus AB. Works. Fun. Okay, so let's give it a whirl. From here to here is 92. So to find the other arc, we have to go 360 minus 92. 360 minus 92, 268. Okay, so then the formula is 1/2. So the measure of angle x is 1/2 268 minus 92. Which is 88. Woo! Okay, let's see in this scenario. This arc here is 140. This guy here is x, and our angle is 40 degrees. So we have the measure of our angle 1. We don't have our second angle, so it is 140 minus x. So let's see how we unwind this problem to get our arc measure. So the first thing we do is we multiply by 2 to get rid of the 1/2, and we see that 80 is equal to 140 minus x. And then we subtract 140 from both sides. Oh no, we have a negative! It's totally okay. We're going to end up with negative x over here, and the two negatives will cancel each other out. So we go 80 minus 140 is a negative 60 is equal to negative x. Divide by that negative 1. X is equal to 60 degrees. Okay, let's look at, oh, we've got some algebra here. I love it. Okay, so let's take our bigger arc. So we have that our angle is x over 2. It's equal to 1/2 times our x plus 70 minus x plus 30. This is like review within a review. This is great. So watch how this simplifies. We got x over 2 equals 1/2. This still gets to be x plus 70. But then this minus is distributed to each piece here. So it's minus x minus 30. Okay, so let's simplify this. X minus x is 0. 70 minus 30 is 40. So this becomes 40. Well, that was convenient. Half of 40 is 20. So we get x over 2. 1/2 times 40 is 20. To solve for x, we need to multiply both sides by 2. And x is equal to 40. Well, that was some fun distributing algebra review. Uh-oh. Next problem. We have our little ship problem. Okay, so let me set the scenario. The danger circle is the area out at sea where a ship is in danger of hitting rocks. So let's, so here's the rocks here. So we want to keep the ship out of the danger circle. Lighthouses are set up to warn the ships. They create a circle with their arc as shown here. So the arc of the light swings, this arc of this light swings, and together they make this bright circle. They create a circle with their arc as shown below. If the boat travels inside this circle, it is in danger. If the boat is outside the circle, which it is now, then it is okay. The arc between two lighthouses, actually I want my pen. The arc between two lighthouses measures 120 degrees. A ship's captain measures the angle from his bow of his ship to the two lighthouses is 55 degrees. So let me get, you can see it. So it goes from here to the lighthouse, from here to the lighthouse. He measured that this angle is 55 degrees. Is the ship safe? What angle must the ship be at in order to still be safe? So we want to see if this guy, so think about this, if he ends up in the circle, now we have an inscribed angle. If we have an inscribed angle, so if we end up inside the circle, if we have an inscribed angle, the angle measure is going to be half of 120. So if we are 160 or greater, we are in the circle, which means we're in danger of pirates, of sharks, of, I don't know why there's a tank on the rock, but there is, of tanks. So let's go ahead and calculate and see what this arc is. Just to make sure, it has to be, as long as this arc is bigger than 0, then we're okay. So let's, and you can see, like, okay, this is 55 in South regard, this is 60. As long as we're under 60, we're okay. But let's use our principle. All right, so 55 degrees is equal to half our arc, we'll call this arc x degrees, minus x. So we double to get rid of the 1/2, and we subtract the angle. -10 equals -x. X is equal to 10 degrees. Yay! So because we have, this isn't 0 or negative, we are outside the circle, so we are safe. Yes! We are safe. Yay! All right, let's take a look at our next theorem. If two chords intersect in the interior of a circle, so you guys go ahead and draw this. We have two chords intersecting, label them A, B, C, D, and then the center one will be E. E is where these two guys cross. Then the product, this is multiply, of the segment lengths of one chord, so like EA and EB, is equal to the product of the segment lengths of the other chord, CE times ED. So there's, these are related, and we use this formula, we're going to use it to solve for different segment lengths. So let's see how this works here. I'm going to use that formula. So 6 times 3, so the ones from the same segment get multiplied together, is equal to 9 times x. So that's 18 equals 9x. We divide both sides by 9. and x is equal to 2. Woo. Okay. Here we get 3x times x minus 1 is equal to 4, or 2 times 4. We're going to go ahead and distribute. So this is 3x squared minus 3x equals 6. Sorry, it equals 8. See, welcome to my morning. All right, so we're going to move the 8 over so we have a quadratic in a x squared plus bx plus c. So we're going to subtract 8 from both sides. See, he doesn't have another number without an x on it to combine with, so he just chills by himself. Now, crazy enough, we are going to quadratic formula this guy. And some of you guys are like, Ms. Elbagarth, how dare you? And I'm like, yeah, sorry. So we're going to get a little quadratic review while we're here. The quadratic formula is our x value is equal to negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Okay, so in this case, a is 3, b is negative 3, and c is negative 8. So we're going to take this formula and plug it in. Just going to create some more space for us. Okay. So it's going to, our x value is going to be negative whatever b is, which is negative 3, plus and minus the square root of negative 3 squared minus 4 times a times c. Sorry, my c went sideways on me. The negative became like a comma. Okay, negative 8 divided by 2 times a. All right, we're going to simplify, simplify, simplify. So negative and a negative make a positive. Negative 3 squared is 9. 4 times 3, sorry, negative 4 times 3 is negative 12. Negative 12 times negative 8. It's 96. Sorry, plus 96. 2 times 3 is 6. Okay, keeping on simplifying, we're almost there. 9 plus 96 is 105. And so think about this. If we take a look at the square root of 105, it is 10.2. Now 3 minus 10.2 is going to give us a negative number. So the negative version of this does not go with our problem because we can't have negative distances. So the one that we have to use is the positive one. So we have to use the 3 plus 10.2 divided by 6. So back to the calculator. Here's my 10.2 plus 3 and then divided by 6. And my answer is x equals 2.2. Yay! I know, quadratic formula, you guys are like, how dare you? I reject all of that. Okay, so let's roll that into Theorem 12:16. If two secant segments meet outside of a circle, like at point E, then the products of the secants, so we multiply them together again, and their external secant segments are equal. So here it is. It's, if you look, okay, EA, it's this piece times the whole thing, boom, is equal to this piece times the whole thing. So we're going to have to watch and sometimes add segments together to make sure we're following this formula. So follow the formula carefully and you'll be okay. Okay, so it is this piece plus the whole, or sorry, times the whole thing. 9 plus 11 is 20. So the first piece to this formula is 9 times 20 is equal to the outside piece, 10, times the whole thing, which is 10 plus x. Sorry, my pen's going rogue here. 10 plus x. So we can do this. 9 times 20 is 180. 10 times 10 is 100. 10 times x is 10x. So we're solving for x here. We minus 100 from both sides. And we get 80 equals 10x. Divide both sides by 10. And we get x is equal to 8. Yay! Okay, let's do that same thing again. We have the exterior piece times the whole thing, which they tell us is 72. And then the exterior piece, 40, times the whole thing. 40 and 38 is 78. So times 78. Oh, my. Ton of brain on a nice Wednesday morning is not going to be able to do that. 3120 equal to 72x. Divide both sides by 72. Divide by 72. And we get x is equal to 43.3. Okay. Another theorem. Look at this crazy picture. Okay, so draw this picture with me. It's a circle. It has a secant that goes from outside through and inside. AB is the chord, E is the point of intersection. And then it's got a tangent that touches at C. So when we have secant, segment, secant and a tangent. Oh, we know those words. The formula is EA, so it's the outside piece, times the whole thing, EB, is equal to EC times EC, or EC squared. Okay, so let me show you here how we're going to use it. So the formula goes the outside piece times the whole thing. The whole thing is x plus 4. Equals the tangent piece squared. So this is x squared plus 4x equals 25. We're going to move the 25 over. Minus 25 equals 0. All right, here we are again. This guy, unfortunately, is not factorable. There are not two numbers that multiply to give you negative 25 and add to give you positive 4. So we're going to quadratic formula this again. So let me quadratic, put it up here. It is negative b plus or minus square root of b squared minus 4ac divided by 2a, where a is 1, b is 4, and c is negative 25. So we're going to throw that into this formula. So our x value is negative 4 plus or minus square root 4 squared minus 4 times 1 times negative 25. Divide everything by 2 times 1. We're going to simplify, 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 so we get negative 4 plus or minus square root. 4 squared is 16. Negative 4 times negative 20 is positive 100. All right, 16 plus 100 is 116. 116 is 4 times 29. So 4 times 29, 4 is a perfect square, so we're going to go ahead and square root that and put it out front. Square root of 4 is 2. And the 29 is not perfect, so it stays under the radical. We are going to divide each of these pieces by 2. So negative 4 divided by 2 is negative 2. And then root 29 divided by 2 is root 29. The square root of 29 is 5.3. Actually, it's 5.4. And we have to dump the minus because negative 2 minus 5.4 is going to give us a negative number, and we cannot have a negative distance here. So we go negative 2 plus 5.4, and we get x is equal to 3.4. I know we get some quadratic in here. I love it. Get ready for that algebra. All right, look at this crazy monster here. We are going to find x and y. We're going to use the segment addition to find our the two little pieces. So let's go ahead and find x first because he's going to be the easiest. So we got x times 12 equals 8 times 18. That is the, let me go back, let me show you which property that is. That's this property here, 12, 15. Eight times 18 is 144. Divide both sides by 12. And x is equal to 12. Woohoo! All right, so with that being 12, we can then use this formula here to find our y. So y is going to be the EC in this formula. EA is the 2, and then EB is 2 plus 12 plus 12. 12 plus 12 is 24, plus 2 more is 26. So when we put together this formula, it's going to be y squared equals 2 times 26, or y squared equals 52. And then, and then we take the square root of both sides. Square root of 52 is 7.2. Da, 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 da. I know, we all want our problems to turn out all just perfectly. All right, you guys take a moment, go ahead and do the homework assignment. It is page 794, 8 through 26 even. 32, 34, and 54. And then come back here and check your answers. Alright, so here's the answers.